Hello and welcome. My name is Felicia Ali and today I would be teaching you about scatterplots, also known as scatter diagrams and scatter charts. So don't be scared if you see or hear either name, they all mean the same thing. Now most organizations use this quality tool for various purposes related to controlling, monitoring and assuring quality management. Our learning objectives today comprises of what is a scatterplot, the types of correlation related to scatterplots, and of course, how exactly do we make or draw this thing called a scatterplot? So to begin, a scatterplot is a graph used to plot the data points for two variables. It is from the plotting of these variable points that a pattern in the end would indicate any correlation. So basically, a scatterplot is used to determine the correlation between two variables to see if a relationship really exists. Therefore, we can say that when it comes to the values of two variables, scatterplots are the best way to present them and is seen to be a very useful, very simple quality tool. Now we are on to our second objective. These are the basic steps for creating any scatterplot. Step 1 is to create a summary table for your two pieces of data, which is essentially your two variables. Step 2 is basically drawing your graph, which is the x and y axes. Now when drawing your graph, you should note that the y-axis, which is this one in red right here, is a dependent variable, and the x-axis, which is the line in blue here, is the independent variable. By keeping this in mind, you would be able to identify which variable goes on the x-axis and which variable goes on the y-axis. This would become clearer as we do an example, so do not be confused, it would all make sense soon. Step 3 is where you go into the plotting of the data points or pairs on the graph you just drew. This usually takes the form of a dot as seen in the little graph here, these little green dots. Now it is critically important that you do not connect these dots or pairs, or else you would be making a line graph, which is totally wrong. Just remember, for step 3, you plot the data points on the graph and that's it. Do not connect them. Now for step 4, most scatterplots have a line of best fit, and this is basically a straight line drawn through the center of the data points you just drew in step 3 to determine the correlation of the data. This is indicated by the yellow line here on the little sketch. Simple enough, right? I hope so. For step 5, since we already drew the line of best fit, it becomes easier for us to determine and interpret the relationship of these two variables in terms of the direction and strength. What do I mean by direction and strength? Simply put, the direction is determined by whether the correlation is positive or negative. The strength, as the name suggests, would indicate how strong of a relationship there is between the two variables. Now we are on to the last objective. That was pretty fast, wouldn't you say? And you already know 2/3 of what scatterplots are. These here are the types of correlation. First we have the positive correlation. This is where as one variable increases, the other also increases. You should know that there can be a perfect, strong, or weak positive correlation. Next, there is a negative correlation, where as one variable increases, the other decreases. Again, you should know that there can be a perfect, strong, or weak negative correlation. In determining if the correlation is strong or weak, all you need to remember is the better or stronger the correlation, the tighter the points will hug the line or simply be closer to the line of best fit. And this would therefore show how much one variable is affected by another. The last step of correlation is little to no correlation, meaning there seems to be no kind of relationship present between the data points plotted. This is an example of positive correlation. If we were being more specific, we would say this is a perfect positive correlation, since if we were to draw the line of best fit in the center, they would match up perfectly with the data points. You should know I made this illustration with M&Ms to keep you interested, though you can't really see it, hence the x and the y axes are not perfectly straight. But anyway, just to note, when you're plotting your data points, both the x and the y axes need to be a straight line, and only your actual data points would be plotted as dots for any scatterplot. Here we have an example of a high or strong positive correlation. As you can see, the points are closely or close to the line of best fit. This indicates that it is a high or strong positive correlation as compared to this graph where the dots are further away from the line of best fit, indicating that it's a low or weak positive correlation. This is an example of a negative correlation. And again, to be more specific, this would be a perfect negative correlation. As you can see, the line of best fit, if it is drawn, they match up perfectly with the data points. Now, this is an example of a low or weak negative correlation where the points are further away from the line of best fit as compared to this one where the points are closer to the line of best fit. And this is therefore a high or strong negative correlation. Moving on, can you guess which correlation is this? Of course, no correlation, right? Well, that's what you were supposed to see. And if you were to draw the line of best fit, you will see this being evident. So great, you just finished all the objectives of a scatterplot. So I'm guessing you know what time it is. It's example time. For this particular example, the information was already given in a table. So step 1 was basically done already. Let's move straight into step 2. I hope you're doing this example as we go along so you gain a practical understanding. If not, I suggest you pause this video, grab a pencil, ruler, eraser, and of course a graph paper, and come on back. When drawing and labeling your graph, you have to figure out where the variables are going. In this particular example, you have temperature and you have ice cream sales. Which one do you think is the dependent variable? Remember we said this is the y-axis. Now which one do you think is the independent variable? Again remember, this is the x-axis. Think about it. If the weather is hot, would you want to buy an ice cream to eat versus if the weather is cold? From that little scenario, can you identify the independent and dependent variable? If you said ice cream sales is a dependent variable and temperature is the independent variable, you are absolutely correct. See, that wasn't hard. If not, try thinking about it again. Wouldn't how much ice cream you sell be dependent on the temperature? Simply meaning, the more heated the weather, the more sales an ice cream truck may get. Understand now? Thus, for the y-axis, which is the dependent variable, we have ice cream sales, and for the x-axis, which is the independent variable, we have temperature. Once you have identified which variable goes where, it is critically important that you figure out your scale. From the table, going back a little, temperature ranges from 11 degrees to 25 degrees Celsius. Thus, for my scale, I used 3 1cm blocks to represent 5 degrees Celsius and went straight until 30 so it wouldn't be exact. Now for my y-axis, going back to the table, ice cream sales range from 185 to 615 and therefore I used 4 1cm blocks to represent $100. And that's pretty much it for step 2. The reason I scaled my graph this way was to ensure that the data points could be clearly seen, since there are questions where the points are closely together and you don't want it to look like one huge point or one thing. Your individual appears to be unidentified. So try to use a big scale so whomever is marking your scatterplot will see everything clearly. Just remember, don't forget to put your title as seen on my graph. Let's move on to step 3. This is basically where you plot your data pairs. Now going back to the table, we can see that the first data pair is temperature 14. So you would go on your graph and locate that on your x-axis, which will be here. And for ice cream sales, it's 215. So you would go and locate that on your y-axis, which would be here, making sure not to lose the temperature point, because it is where these 2 points meet that you get your first data pair. This is indicated by the blue arrow here, which I just used for illustration purposes. All you have to do is plot your data pairs, and this is essentially how step 3 looks when all the pairs are plotted. A quick tip would be to count how many data pairs you have and make sure they correspond with how much dots you plotted. In this example, there are 12 data pairs and also 12 correctly plotted data points. This ensures you don't forget a data pair. Next, for step 4, you draw the line of best fit in the center of the data points. Upon completion of this line, we move straight on to step 5. Can you remember step 5? If not, please review your steps because they are critically important in understanding and making of scatterplots. So for step 5, basically when you draw that line of best fit, remember when I said the more tightly the points hug together or closer together to the line of best fit, the stronger the correlation? Well, in this particular example, the points were pretty close, and therefore it suggested a strong positive correlation. Reason being why it was positive was because as the temperature increases, the ice cream sale also increases. And that's it. That was our objectives, and you just did an example. I have a very short activity for you to do just to recap and tie in back everything to it. So let's get straight into it. What type of correlation is shown in the scatterplot below? Look at it carefully, remember the line of best fit, visualize it, and then see which answer best describes the scatterplot. Ready? The answer is a negative correlation. If you were to draw the line of best fit, you would see that as one variable increases on the x-axis, the other decreases on the y-axis. Remember that was the definition of a negative correlation? Let's move to the last activity. For question 1, which type of correlation is best displayed in the scatterplot? Think about it. If you said strong positive, you are correct. Remember again direction and strength. As one variable increases, the other also increases for direction. And the more tightly the points hug together to the line of best fit or closer to the line of best fit, that indicates how strong the relationship is. And this therefore indicated a strong positive correlation. Once you got through with question 1, question 2 should be a piece of cake. So, which statement relating to scatterplot is true? Read them through carefully. As you can see, as study time increases, test score also increases. As study time increases, test score also increases. So that's the answer, and there you go. This brings me to the end of my video. I hope you enjoyed and have learned a lot about scatterplots. Thank you for watching. The end.